Imagine sailing west into the North Atlantic. No magnetic compass, no chart showing your position, no GPS, and after several days, no land in any direction. A modern sailor would probably ask one question first. Where are we? A Norse navigator may have been asking something slightly different. Are we still going the right way? That difference is the key to understanding how Viking Age sailors crossed the North Atlantic. They did not need to know their exact coordinates. They needed enough information to maintain a useful course, recognize when they had drifted, and detect land before they sailed past it. And instead of relying on one perfect instrument, they could combine many imperfect clues. The sun, the stars when they were visible, the wind, the swell, birds, whales, clouds, the color and character of the sea, landmarks remembered from earlier voyages, and most importantly, experienced people who knew how all those clues fit together. The secret of Viking navigation was not a magic device. It was a system. Most Viking Age sailing was not even done hundreds of kilometers from land. Ships traveled along coasts, through fjords, across straits, and up rivers. That created generations of sailors who became extremely good at reading landscapes from the water. A mountain does not look the same from every direction. Neither does a headland. An island can change shape as a ship passes it. A navigator could remember which peaks aligned with one another, where dangerous shoals lay, where a river entered the sea, or what a particular coastline looked like before a harbor appeared. Even place names could function as memory aids. And when sailors entered unfamiliar waters, the smartest piece of navigation equipment they could carry was sometimes another human being. Someone who already knew the route. The Old Norse idea of a leiðarmaður was essentially a man who knew the way. He did not need a digital display telling him latitude and longitude. He needed a mental map. Directions could also be transmitted from one voyage to another. Later, medieval Icelandic texts preserved sailing instructions that describe routes through relationships between places rather than coordinates. Shetland, the Faroes, Iceland, Greenland. How far one land should appear from another? What side of an island to pass? What signs suggested that land was near? The navigation system could live inside stories, place names, habits, and people. Before we continue, my name is Noah. We built this channel for people who want to understand how people in the past did things that seem almost impossible today. If that sounds like you, subscribe. It is free and it helps us make better videos more than you might think. All right, back to the Atlantic, because eventually the coastline disappears. And this is where the famous Viking ship matters. But probably not the ship you are imagining. The iconic longship was built for speed, shallow water, raids, warfare, and carrying large crews. For long-distance trade and settlement, Norse sailors also used broader cargo vessels known as nars. These ships were fuller and more robust. They had large cargo capacity and were driven mainly by a square sail. Written sources specifically associate the nar with voyages to Greenland. That matters because crossing the Atlantic was not just about moving warriors. Settlers needed tools, food, timber, animals, clothing, trade goods, replacement equipment. Everything required to survive after landfall had to survive the voyage too. The hull mattered as much as the route. A broad cargo ship could carry stores for a long passage, while its clinker-built planking created a strong but relatively flexible structure. The square sail converted North Atlantic wind into the force that made these migrations possible. Before navigation could work, the ship had to survive being uncertain. If bad weather pushed a vessel off course for an extra day, the crew needed food and water. If the wind turned against them, they needed a hull capable of remaining at sea. If they reached the wrong part of a coast, they needed enough endurance to correct the mistake. This was not precision navigation in the modern sense. It was resilient navigation. And here is the part that changes how you should imagine the entire problem. A Viking navigator did not always need to know exactly where the island was. He needed to keep the ship inside a corridor that made finding the island increasingly likely. Think of Iceland on a blank map. If you know roughly which direction west lies, if you know how the sun should behave along the route, and if you recognize the environmental signs that appear as land gets closer, you do not need a continuously updated coordinate. You need to avoid making one enormous error for too long. That is a much more achievable problem. The sun was one of the most reliable reference points. Even without an instrument, An experienced sailor could use sunrise, sunset, and the sun's movement across the sky to estimate direction. Around midday in the northern hemisphere, the sun gives a southern reference. Its height also changes with latitude and season. Modern researchers have shown how a simple shadowboard or sun compass could theoretically help a sailor maintain direction or remain near a chosen latitude. There is archaeological material that has been interpreted as part of such a device. But this is important. We cannot simply say every Viking ship carried a sun compass. The evidence for actual navigation instruments is thin, and some scholars dispute whether famous wooden discs were navigation devices at all. So the safest answer is not that the Vikings replaced the magnetic compass with another compass. It is that solar observations could work with or without a specialized instrument. At night, the North Star could indicate north. But there was another problem. Viking voyages were often made during the brighter northern sailing season. At high latitudes, summer nights can remain so light that stars are difficult to see. So celestial navigation could not solve everything. The environment had to provide other clues. Birds were useful because some species remain within a limited distance of land. Seeing more coastal birds could tell sailors that something was changing. Their flight direction could sometimes suggest where land lay. Whales could indicate particular feeding grounds and currents. Clouds could form differently over land and sometimes reveal an island beyond the visible horizon. Closer to shore, smells, sounds, fresh water, floating vegetation, or changes in the sea could all become information. And then there was the movement of the ocean itself. To an inexperienced passenger, swell is just the ship rising and falling. To someone who has spent years at sea, it can have direction. A persistent swell can outlast a local change in wind. If a sailor knows the usual behavior of a route, the movement beneath the hull can help him understand what the weather above it is doing. Now put the system to the test. You are leaving Iceland. Your destination is Greenland. Between you and it is hundreds of kilometers of North Atlantic water. No coastline to follow, no lighthouse, no radio. This is the midpoint where Viking navigation stops being an abstract skill and becomes a survival problem. No single clue is perfect. That is the point. A bird can mislead you, a cloud can disappear, the sun can vanish, the wind can change. But several clues pointing in the same direction are much more useful than one clue alone. The Norse settlement of Greenland is traditionally associated with Eric the Red in the late 10th century. According to the sagas, Eric had heard of land to the west before he went looking for it. That is another important correction. The westward expansion was not necessarily a sequence of sailors pointing a ship toward an empty horizon and hoping a continent appeared. Information traveled before settlers did. Someone sees land, someone returns with a story. Another crew tries to find it again. A route becomes knowledge. Then knowledge becomes migration. When Eric later returned to Iceland and encouraged colonization, multiple ships attempted the voyage. The saga tradition itself preserves failure. Not every ship reached Greenland. Some turned back, some were lost, some may have been driven elsewhere. That is what real navigation looks like. Not magic, a method that works often enough to create a settlement network, while still failing often enough to kill people. On the voyage west, the crew could use the sun when conditions allowed. They could compare the direction of the wind with the motion of the waves. They could estimate progress from time sailed, though wind and current made that uncertain. They could watch for birds, they could notice changes in weather or sea conditions. And once Greenland's enormous ice cap or mountain coastline entered the horizon, the problem changed again from open ocean navigation to land recognition. Reaching Greenland did not necessarily mean arriving at the harbor you wanted. A landfall far north or south still had to be corrected by sailing along a dangerous coast. Fog, sea ice, storms, and unfamiliar fjords could turn the final stage into a second navigation problem. That is why experience mattered so much. A modern navigator can separate knowledge from the person using it. The chart is printed, the satellite gives the position, the compass gives the heading. For a Viking Age crew, much more of that information could exist only inside the navigator's memory. Lose the experienced sailor, and you might lose the route. And this brings us to the object that supposedly solves everything. The sunstone. You have probably heard the story. Clouds cover the sun. The Viking navigator raises a crystal. He turns it toward the sky. The stone reveals exactly where the hidden sun is, and the ship continues perfectly toward Greenland. It is an incredible image. There is just one problem. We do not actually know that Viking sailors used sunstones to cross the Atlantic. The idea is not nonsense. Certain crystals can interact with polarized skylight in ways that can help estimate the sun's position even when the solar disk is hidden. Modern experiments have tested candidate materials such as calcite, cordierite, and tourmaline. The physics can work under useful conditions. But proving that a method can work is not the same as proving that historical sailors used it. No clearly identified Viking-age sunstone navigation instrument has been recovered from a ship or settlement. That absence does not prove no sailor ever tried such a technique. Organic tools disappear, shipwrecks preserve only fragments of past equipment, and navigation knowledge can vanish without leaving a trace. It simply means the claim must remain a hypothesis rather than a recovered Viking instruction manual. Medieval texts mention sunstones, but the famous references do not give us a Viking navigation manual explaining how Atlantic sailors used one. So the most responsible conclusion is also the more interesting one. Maybe some Norse sailors used solar instruments. Maybe some experimented with crystals. Maybe techniques existed that archaeology has not preserved. But we do not need a magic crystal to explain how the voyages were possible. The rest of the system already gives us a plausible answer. And the strongest evidence is not a navigation tool. It is what happened next. From Greenland, Norse sailors kept moving west. The sagas describe voyages associated with Leif Erikson and other explorers toward lands they called Helluland, Markland, and Vinland. The details of those stories were written down later and cannot be treated like modern ship logs. But one fact is no longer dependent on the sagas. Norse sailors reached North America. At Lonso Meadows on the northern tip of Newfoundland, archaeologists uncovered the remains of an 11th century Norse settlement. Timber-framed turf buildings resembled structures from Norse Greenland and Iceland. The site contained evidence of ironworking and ship-related activity. It is the earliest confirmed European presence in North America, and it existed thousands of years after indigenous peoples were already living on the continent. That distinction matters. The Norse did not discover an empty America. They crossed an ocean and reached a world already inhabited. We may never know every decision made on those voyages. We do not know exactly what instruments every crew carried. We cannot reconstruct every cloud they followed, every bird they watched, or every correction they made when the wind shifted. But we know the voyage happened. Because the Norse left something better than a navigation manual. They left a settlement. And that brings us back to the ship in the empty Atlantic. No magnetic compass, no chart with a little dot showing your position, and no machine telling you that Greenland is 600 kilometers away. Just a vessel, a crew, weather, memory, and a landscape that begins long before land becomes visible. The Vikings crossed the North Atlantic because they had learned to turn uncertainty into information. The sun gave direction. The stars could help when darkness allowed. Birds and whales could suggest proximity to particular environments. Clouds could hint at land. The sea itself could carry patterns. Coasts and mountains could be memorized. Routes could be passed from sailor to sailor, and ships could survive long enough for mistakes to be corrected. The remarkable thing is not that Viking navigators always knew exactly where they were. They almost certainly did not. The remarkable thing is that exact position was not always necessary. They needed to know enough. Enough to hold a useful course. Enough to recognize when the world around them was changing. Enough to find land. And enough to teach someone else how to do it again. The secret was never one compass. It was an entire way of reading the Atlantic.